So, our training session today is going to be led by our very own Alan Sidford, who I would personally say is an absolute expert on dragonflies. He seems to know everything I ever ask him about them anyway, and has been very good for helping training a number of us up over the last couple of years out and about in the forest. So before we make a start, there's just a couple of little bits of housekeeping I need to make you aware of. So as per normal, we're muting everybody's mics just so we can reduce disruption through the session. So if you could keep them muted, that'd be great. We are, of course, very welcome to people asking questions as we go through as well. But if we could ask that people put it in the chat, which you'll find at the very bottom of the screen, that would be wonderful. And we'll make sure to work our way through those at the end. We're also recording this session so that we can reuse it in future to help revitalise your knowledge as we go along. We've now almost recorded every single session we've done, which should be hopefully available to you very shortly. So I think if we're all happy and raring to go, I will now pass over to Alan, who will lead today's session. Go ahead, Alan.
Okay, thanks, Jonathan. For those of you, as Jonathan said, quite a few of you haven't met me. The volunteers should have done by now. I'm a volunteer with the Trust. I volunteered like most people doing trees, guards, forestry work. But unfortunately, my knowledge of dragonflies and that was found by Sophie, so I sort of moved over to the biodiversity part for some time to help with surveying them within the forest areas. We'll run through a presentation I did for them about 2 years ago, and I'll sort of try to get into that now. Hopefully we'll get into it. Right, so this is an introduction to dragonflies and damselflies. It would be possibly easier to produce a slide showing you the 5 or 6 or so damselflies and the 5 or 6 dragonflies that we find common within the forest, and just go through how to identify each one. But I've had quite a long time interest in dragonflies and damselflies. So I've put together a presentation called an introduction to. So we'll go through it and hopefully give you some insight into what they are, where they came from, and where they fit into the insect area. So this is basically the front end sheet that we had at the first one. Because it was held in the barn, we had a first session, coffee break, second session, and then after the lunch break we went out for a third session of physically checking on one of the ponds, walking around with 2 or 3 dragonfly surveyors and giving you a chance to try to identify what you've learned. We'll be following the first 2 parts of it, but the third part, the pond visit, we're hoping to arrange in the near future. We can talk about that at the end. So first of all, I'd like you to give these a thought. These are some of the things that have come to me while I've been talking to people about dragonflies in the past. It's a true or false answer. That's all you need to think about at the moment. So dragonflies can give you a nasty bite, true or false. Dragonflies can give you a nasty sting. Dragonflies fly at your face. Dragonflies die after mating, and dragonflies make a noise like a very angry bee. All of these are true or false answers. Hopefully we'll go, when I go through all the slides, you should be able to answer these quite easily at the end. So what are we talking about with the dragonflies? Dragonflies and damselflies come from the order Odonata. Odonata translates roughly to tusked jaw. This gets its name from the actual jaws of the dragonfly or damselfly. They're overlapping sort of shears that cross one another, and the front edge is serrated, so it gives it a tusked effect. The Odonata series in England, at least, is split into 2 parts. Zygoptera with similar wing, and the Anisoptera with dissimilar wings. By similar wings, they're roughly the same shape, front and rear wing for the first section. And the dissimilar, they're certainly different in shape between the two. They're not identical when we say similar, they're just a similar shape. That then shows us that the similar shaped wings are the damselfly and the dissimilar are the dragonfly. Now, with the talks I gave before, I actually handed out a piece of paper which was split in half vertically down the centre, with damselfly one side and dragonfly the other side. And as we went through the talk, you could write on one side what was applicable to the damselfly, like similar wing, and on the dragonfly side, dissimilar wing. So it gives you an idea, a breakdown of what you're looking for between the different two groups. And what I've produced here is a basic timeline to give us some idea of where they fit in and where they fit into the history of animals. To start with, there's us now at present, and that's today, sitting here. But as the course goes on, we'll be, of course, adding on to that, so time isn't static, ever moving. So let's have a look first at Homo sapien, the modern man, us. We've been around for about 3,000 years. No, 300,000, sorry, years. Quite a while we've had time to develop. Australopithecus is 4 million years. Australopithecus is roughly one of the ancestors that we come from, we divide off from. So running alongside us through that period of time have been all the other types of hominids, Cro-Magnon, and sort of the rest of them, all running in parallel. So we're in parallel system. They've all died out and left us as being the only ones still surviving. We go back to this one, 6 million years ago, and this is where they believe we split away from the great apes. So therefore, at this point, we left the gorilla, chimpanzee, bonobo, all of the rest of that type of great ape species. Further back, let's go back in time a little bit more. Tyrannosaurus rex, our favourite dinosaur. Great carnivores, dinosaurs like Tyrannosaurus lived about 65 million years ago. So Hollywood's idea of man fighting against Tyrannosaurus rex is out by about 65 million years. But it's close enough for Hollywood. Of course, their favourite food was Diplodocus, things like that, the giant herbivores. Well, they died out 153 million years ago and were already fossils by the time the Tyrannosaurus and so arrived on the Earth. 80% roughly of the present day Odonata series were around 250 million years ago. So that's some of our dragonflies now are direct descendants of the ones that were there then. Some are paralleled off from it and split off from it since, but quite a fair number have been around for 250 million years, which is quite impressive considering the amount of time we've been around and mocked everything up. The Troodonta, roughly 300 million years. These were believed to be the predecessor of the Odonata series. Slightly larger, they had slightly different characteristics, and one of those we'll mention later. Further back, we come to these Meganisoptera, 359 million years, roughly. I mean, you can take off sort of 20 million if you like at that sort of time. These are the ones of the fossil records where you get the very large dragonfly-looking insect. The largest one found to date is about 70 centimetre, 700 millimetre. So you're talking about something about the size of a magpie flying around and it's a dragonfly type creature. And we go back further still to the first insect emergencies, which were roughly about 480 million years ago. So we're looking at a long period of time from these 480 million years right the way through. Around the Odonata period, or the 300 million year period, this is when we lost the majority of the insects that came out of the original emergence from the ocean. It left us with four groups. The four groups are basically Odonata, which is traceable beyond that 300 million, Ornithopter, which is the cricket and grasshopper series, the mayfly, which we all know, still around, and the true bugs. There's quite a lot of those, so you know, it's a fair amount of insects spread across four groups. So we're going to the first part now, and that's basic anatomy. What I want to do is go through the basic anatomy of an insect, just to get you back into your school anatomy, school biology lessons. So we're basically there, we're showing a sketch of a damselfly and a dragonfly. I'll get the cursor again. First thing we'll look at is this pterostigma. We'll call it a wing spot. I don't want to go too much into Latin, Greek, scientific, which it is. It's a cell towards the end of the wing, which is generally a different colour, so it's visible. Within the damselflies, the eyes are separated. They're on both sides of a rectangular or slightly triangular head to either side. The thorax, the central bit of that, contains all the legs, 6 legs, so it's an insect. And in the case of the dragonfly series, Odonata, we've got 4 wings. And this is what we mean by similar wing. The wing pattern and shape is roughly the same. It doesn't have to be exactly the same or the same size, but it's roughly the same. Abdomen, down here, we'll go through these again in a second or two in a bit more detail. We split these into 10 sections, and I've highlighted S2, S8 and S9 specifically on damselflies because they're recognition points on the damselfly. S2 has a special pattern banding on it that helps identify it, and S8 and 9 generally have colour coding on there that can help. With the dragonfly, the eyes are much larger, in both cases they're compound eyes, much larger, and they touch in the centre of a spherical head. So if the head's round and covering most of his body, most of his head, it's a dragonfly. Thorax is similar to that we looked at for the damselfly. And the abdomen, again, is split into 10 sections, and the coloration and banding of that can help us identify. Now, at the very bottom end, we have on the males what are called claspers. We'll see those and understand their use in a bit. The female have streamers, clasper type things, but they also have the ovipositor, where they lay the eggs. These are quite pronounced on certain of them, hence people think they've got a sting, but of course it's not a sting, it's for laying eggs. And the genitalia of both the male and female are present at S10. Now, quite surprising to most people, is that the Odonata series is unique. And it's unique for one special reason. The male has an accessory genitalia underneath S2. No other animal has that. So if you go on, we'll look at each part in a bit more detail. Starting with the damselfly, there are his 2 compound eyes positioned on either side of his head, with a central piece in between clear. So the damselfly never has touching eyes. so it's easy to recognise him now. These compound eyes give him 360-degree vision across into both the horizontal and vertical planes. He can see all around him, forwards, sidewards, towards the rear and over his back. The only place he can't see would be under his body shadow, where his body would interfere with his vision. The compound or the cells within the eyes form, we believe, a single image, although they're separate sort of receptors. The receptors are different sizes depending where they're positioned on the eye and what they're used for. They're much larger at the front, where they need to locate prey and detect prey. Slightly smaller to the sides, there's no reason for them. And a few large ones back here somewhere, and then smaller ones again. So he's giving himself a maximum position on that for vision. In addition to that, he has three sort of inferior eyes. They're inferior in that they're not vision eyes, they're light detecting eyes, and they're set in an equilateral triangle on top of his head, with the point of the triangle being where our forehead would be, and the other one's two further back on his head. These eyes aren't wired in any way to his vision system. They're not used for vision. They're directly wired to the muscles of his wings. These create for him an artificial horizon. So as he turns and dives and moves, he records different levels of light as he's turning. So he knows where he is within the space he's in. If we look at the dragonfly, we can now see the reason why the eyes differ. The spherical head, very, very large eyes, and they touch in the middle at that point. He's got the same eye pattern, triangular eye pattern, to give him this artificial horizon. And in this photograph, we can actually see the front part of his face there, and then below that would be his jaw. This can be important in the identification of dragonflies. This is the frond, or fronds, something. We go through to the thorax, the central part of the insect. You can see the head's connected with a very, very small neck-type section, but actually that is also the thorax of a damselfly. It's a prothorax. And when they're mating, which we'll see later, the male attaches behind that first point there. So if I talk about pronotum shields, things like this, it's that part of it. The thorax basically contains 4 giant muscles, one for each wing. They're each independent and they're very large. Attached also, you'll find to this prothorax there, the front 2 legs, and to the main thorax, the rear 2. And while we're in this section, we'll look at the wing structure. We'll go back to the wing here, and you'll notice that the wing on the damselfly is aligned down the length of the body, not out at 90 degrees, as you'll find in all of your books and reference documents. That's purely to allow you to try to identify. In the field, it makes it complicated because we're looking at S1, S2, which is there, and we're trying to look at marks at that point with his wings closed. So sometimes we're looking through wings or to the side of the wing. Dragonfly is in the typical pose there with his wings held out in a cruciform position, as you'd see in your referencing books, 90 degrees to the body, splayed out. They don't land with the wings down the length of their body. They could do. There's no reason why they can't land with the wings down. It's just that they don't. The wing joint there, where it attaches to the thorax, and again there to the thorax. is more or less a sort of universal joint, and it allows this wing to be moved in more or less any direction that it wants to. So since you're all getting a bit tired, getting up so early and all that, we'll do a bit of aerobics now. So if you're lucky because we do this in the barn visually, so everybody has a laugh, but you're at home now, so you can do it. If you hold your right arm out horizontally from your body, and your thumb should be pointing forwards. Your thumb now is the pterygstigma, the wing spot. And from that position, we'll move our hand forwards and down, about till we come 45 degrees to the body. At that point, turn your hand over, so this wing spot is turning over, it's vertical, it turns back towards the back, and we go backwards up to where we were before and dive downwards in a downward arc. The thumb rotates again, pterygstigma comes to the front, and we come back to where we started. So you should be drawing a figure of 8 in the air to the side of you. That's basically the wing beat of the dragonfly, sweeping in this figure of 8 pattern. We now consider we can do that with the other side. So we've got the two working together. But we've also got two behind. We're not a true fly. We've got two at the back. We can now use those in exactly the same way as the front and working with the front. So we get forward motion as fast as we can move our wings. If we now relate that more to something we'd understand, if we consider a 4 people rowing a rowing boat, because that's what we're really doing, we're rowing our way through the air, not flapping. If we consider those 4 people and we all pull together as a racing team, we'll go forwards very quickly. If we want to slow that down, but still maintain a reasonable pace, the 2 people at the back can alter the rate that they row at. And if we get it correct, we can start to balance ourselves out. And that's the point where the dragonfly offers, and he's using both wings at different wing beats front to rear. If we're now consider we're rowing forwards at full speed, and the 2 people on the left turn their blades vertically to grab water, we'll spin round to the left. So the dragonfly now feathers 2 wings on one side and he turns rapidly to the left. Because he's not in water, he's in the air, and the whole of the air is where he can fly. If he really puts pressure, back pressure against that side and accelerates the right-hand side, he can do a barrel roll. So he's very maneuverable in the air. Now, let's consider those wings in a different way. The wing beat of the bee, which we've all had a talk on bees the other day, wing beat of the bee is somewhere between 230 to 300 times a second. It's very fast. He's only got one set of wings really, so he has to go very fast. And because of that speed, he creates a sound, a buzzing sound, humming. So that's where we get the sound from, a bee. The dragonfly on the second, you wouldn't do this figure of 8 maneuver at turning at that sort of speed. Dragonflies beat at about 30 beats per minute, per second. And at that sort of speed, no sound is made at all. So the dragonfly is a silent hunter. The only time we'll probably hear him is if he crashes the 2 wings together or hits a piece of vegetation as he's flying along. Moving on to the abdomen part of it, this is on the left the abdomen of a damselfly. We'll see this one again later and I'll tell you which ones they are later. Abdomens contain, obviously at the very bottom of it, the sex organ, and in the male under S2, which is below that point there, and that's a recognition point for this particular damselfly. Under there is the male accessory genitalia. The rest of it is taken up with digestive systems, other internal organs, but also their breathing mechanism. As an insect, It doesn't breathe through its mouth. It hasn't got lungs. It breathes through spiracles, small holes within the side of the abdomen, which allow oxygen or air to flow in. The oxygen is extracted through membranes within there and passed into the internal part of the body in the dragonfly. The interesting thing about these is if you look at the damselfly compared to a dragonfly, they're quite different in proportion. The damselfly is basically a very thin cylinder, slightly expanded at the rear end if it's the female, where the ovipositors would be. But the dragonflies are a more powerful built figure with a much larger abdomen. Some people use it as identification, but you don't really need to do that because of the size of them when you actually get out in the field. If we look again, what I said earlier, the wing here is roughly parallel to the body. This one's relaxed slightly, but generally a damselfly will be directly down the centre line of the abdomen there. And you can't make out, but they're roughly the same sort of size, look very similar. This dragonfly here, you can obviously see they're out in cruciform position. And you can see the trailing edge of this wing is very, very deep out at this point. And we'll talk more about the wings when we get on to the evolution of the actual life cycle. This is a point that if you'd have done with me 2 years ago and also being present at the time, you'd have answered a question on QI that fooled all of the people answering the questions. This is the kill ratio, the sort of ability for these insects to actually kill targets they go for. And I've put them up against two other contenders that we like, the lion and the great white shark. If you look at the lion to start with, you've got an incredible kill rate of about 40%. Basically, we're talking with lions and big cats like that. They're as much scavengers as they are hunters. They will actually take food off other animals that have killed it, or they'll pick up food or animals that have died. Yes, they've got a very keen sense of smell. They've got good vision. But they're also a stealth attack. They haven't got that endurance to catch up with things. Possibly more related than a lion. If you take into consideration a cheetah, who's a chaser, they would locate a prey and then run after it, following it, as you've seen on most of the nature programs. If that prey can carry on long enough, it'd have to give up. It's only got short bursts of speed. If it can jump to the side quickly, it'll miss its target and the prey can run away. So really, as an effective killer, they're fairly low rated. The great white, that's gone from 2 minutes, great white shark, it's about 60%. We all think they're potentially brilliant killers, but they've got a very complex array of equipment: sight, smell, electromagnetic detection. They can detect water movements, vibrations. So they can move up on things, but still they don't kill every time. Their rate is around 60%. Odonator dragonflies, about 98%. Reason for this, and we'll see as we go through different parts of it, but the reason for this is those massive eyes. They're really big. They can detect prey at quite a distance. They're also capable of looking into the infrared, which means, like most of the aquatic type insects, they can see polarized light. So they can pick up prey as dark objects against a white background, a very light background. Okay, I'm losing my voice already. But the other thing they're capable of, and it wasn't known until fairly recently with very, very high-speed photography and putting tags on the dragonflies and monitoring them within an enclosed environment. One of the types of dragonfly that we'll be dealing with is called a darter, and he sits on a plant looking around, waiting for insects to come past. When he spots an insect, you'll see it shoot out, grab the insect and come back to usually the same perching point that he was started from. Now, unlike the leopard, he's not following that insect. Dragonfly are capable, and all of them, even the ones while they're flying, are capable of detecting a target, understanding how fast that target is going, and what direction, what speed, correcting for any wind at the time, and they will fly a course to intercept that target at a distance. So he won't chase after it, he'll actually intercept it. So it's very complex. That's the equivalent of a modern fighter plane using their latest weaponry. They intercept at distance and don't fire. Right, so we're finally getting on to having a look at the little insects themselves, their life cycle. That's the life cycle of a typical dragonfly, well, all of them. As you can see, the blue line effectively is the water level. Below that, it's in an aquatic environment. Above it is terrestrial environment. Whether these insects are terrestrial or aquatic is still in debate, very much so, because it lives most of its life underwater, but some of its life above water. But if you look at that logically, forget for the moment the word tenor and just look at adult, you'll see there is only egg, larva, adult. So there's one thing missing for an insect, a pupa. Dragonflies don't have pupa. They only have 3 stages to their life. And this is one of the indicators of why they're an ancient insect. The other insects I mentioned, the mayfly, the crickets, also have a 3-phase life. So looking into it a bit more deeply, we won't start at the egg. We won't go into which comes first, the chicken or the egg. We'll start with the larvae. That's the typical larval nymph. In this case, it's a larval nymph of a dragonfly. For those of you doing pond dipping, so that's you educational people, Phil, if you catch these things in the pond, you can identify the two from one another. I haven't unfortunately got a damselfly on here, but if you look right at the very back of the abdomen there, you'll see 2 small spikes. Those spikes are the breathing membrane, the gills in effect of the animal, and it extracts water from around there. It also sucks water into its body and absorbs water within its body cavity, and then just squirts it back out again. That gives it an advantage in the form of a dragonfly, in that if it's attacked, it can actually use that water within its body as jet propulsion. Push the water out quickly and it shoots through the water away from any prey. Unfortunately, I haven't got the damselfly, but you'll see it in your books. The damselfly has 3 feathery-like appendages coming from the rear part. Those are the gill, in effect, sticking outside the body, the 3. And it does not use the water side of it. This particular dragonfly is fairly flat. Larvae, you can see it's flat. This would indicate there's leaves within the leaf litter and plant litter down towards the very bottom of the pond. It's not very good for crawling around in plant and foliage at eye level. This is a low level one. And if we look towards the front there, he's already got big compound eyes. There, he's already got 6 legs. He's already got this very large mouth, which I'll talk about in a second. And you can't really see it, but that part going down there and around there, he's already got wings held within this case. This case itself is extremely waterproof and it's hard. It's like crustacea, like a shrimp or a prawn. So therefore, the only way this could get bigger and grow through its life cycle is to shed this case, come out of it as a soft-bodied insect, and then that will harden off within an hour, 2 hours at a larger size. It'll pump it up as it's soft, and then it'll harden off again. Each of these stages are called instars, and depending which we're looking at, whether we're looking at a damsel, small damselfly, or some of the dragonflies, this can vary the number of instars it has, from anything from 3 or 4 to 12 to 13, 14, depending on the environment and the climate it's living in at the time. The fastest ones we've got have turned round are probably the emerald damselfly, which will sort of come out of its egg, go through its instar stage, and become an adult within a year. So it'll hatch very early in the summer, very early in the year, and it'll be flying by August, July. The longest one we have is a dragonfly called a golden ring dragonfly. There's actually a photo of one later in the thing. It's golden ringed dragonfly. Its habitat is across the south of England, the coast, and inland slightly, across the south of England, cutting across Devon, Cornwall and Somerset, so it's present in all of those counties, up the coast of Wales, up the Lake District coast and into Scotland. Seems a strange area to be in. You won't find it in the Midlands, or if you do, it needs reporting. And you definitely won't find it in Lincolnshire, that sort of east coast area of Britain. The reason for this is it likes a moist, warm climate. So if you track that area we've just gone round, you'll also track the Gulf Stream, and that's where it loves from. But in the south of England, the golden ring, will have a lifespan as a larva of about let's say 2 years, average, about 2 years. In northern Scotland, you could be talking about 5 years. The reason simply for that is up north, the water's colder, so the food it can get is lower, and the growth in time is shorter per year. So the growth of these is dependent on the type of environment they live in. Finally, as we look at the larvae, these also are carnivore, which I didn't say at the beginning, but all of this series are carnivores. They'd never touch a piece of vegetable matter if you try to force them to. They all eat carnivores, and some are cannibalistic as well, even from the very early stage here. The jaws of this, they're set below that part there, and the lower jaw is actually hinged. So it goes from the point under there down to about here on its body to an hinge mechanism, back up to an hinge mechanism just under the head. That whole section can shoot out forwards, grab a prey and drag it back into the mouth to be eaten, to be chopped into pieces. This is a very sort of strong bite. It can go through beetles or any insect that is living at the moment. These could just crunch through as if they're not there. But even if you had a dragonfly sit on you, which is quite common when you're surveying, its bite is not strong enough to break human skin. So no one has ever been bitten by a dragonfly. The damsel, a nymph like this, I wouldn't advise picking it up, because it would sort of, if it did pull any skin backwards, it might sort of pinch it. It won't break the skin, it might pinch it. But this movement is so quick, it's hydraulically based. Again, it's in water, it uses that. And it pumps the water up. I'll get back in a minute. Pumps the water inside and it shoots this forward. It does that so quickly that if a larger one is attacking a prey like a small fish, if it misses the first time, there is a very good chance of it catching it the second time. It's so fast. We move on from that, we'll go on now to a teneral stage. This is actually the adulting stage, but it's the first part of it, it's the teneral. The thing you can see at the bottom there is the final stage of the larval stage. So everything's present as it comes out of here in this final insect. It's called an exuvia. I've got to use that term because there is no other term for it. It's the scientific term, exuvia. It's the final larval stage, so it finds a suitable plant growing out of the water and it climbs up that plant. It may actually move inland 2 meters or so and climb up the reed there or a plant to get to a position. When it gets into that position, there, the legs, the first thing that happens is the legs lock onto this, whatever it's called, its support. From that point onwards, the outer case is dead. And it then splits down a line down the back of the thorax to the top of the abdomen and across between the two eyes in a Y shape. And the dragonfly then, I haven't got a photograph unfortunately, falls outwards and hangs down there. So its abdomen is still in here, but the thorax and head are hanging down with its legs sticking out and the wings folded against its body. It'll remain like that for whatever length of time, depending on each insect. And then purely that time is for its legs to harden, to become strong enough to support its own body weight, at which point it swings its body round from this hanging position onto there, and using its legs, it pulls itself up to this position, away from the exuvia. It'll also look around and try its best to see that it's on a freestanding stem out in the open and not near another stem. That's why the next thing it will do will pump fluids that it's got retained here and in here. It'll pump those now down into its abdomen to extend its abdomen to full length. When its abdomen of body is at full length, it will pump body fluids into the wings. The wings are here at the moment, or would be there at the moment. Now it pumps them full of fluid until they're fully extended, or as far as they will go. Sometimes you see them deformed if they touch a plant en route. That deformity is there permanently, simply for the reason that the fluid is pumped into the wing, it expands to its full size, and then the liquid is pulled back into the body. What that's done is the equivalent of an Easter egg. If you think of a large Easter egg, you pour chocolate into the mould, shake it around a bit, that starts to harden on the outside, and then you pour the rest of the chocolate back out again. So you leave a thin shell. So these wings are made up of hollow tubes, hollow veins, lots of them. They then sit in this position, the teneral. It's in a very delicate position. It's very, very soft. It's very, very vulnerable. Birds can now attack it because they can see it. Other insects can attack it. Bigger dragonflies can attack it. So it's there and it's dicing with its life. It has to wait until it's now hardened off enough and become strong enough, firm enough, at which point, when it's reached this firmness, it will make a teneral flight, its first ever flight, and that flight will be vertical, and when it reaches an altitude, it will head off away from the pond, well away from the pond. All of us think of dragonflies and damselflies as water-loving animals. We always see them, or we mostly see them at ponds, rivers, lakes. But as a young dragonfly or damselfly, they're very, very vulnerable. So it's a very dangerous place for them to be. They can be attacked. As soon as they fly off, they can be attacked, or not attacked, but a male may appear if it's a female and attempt to mate with it, but it's so soft it would probably kill it, even attempting to grip it. So it doesn't want to be there. And if you look at the condition of this, the wings are completely transparent. Nothing like the ones in your guides. If you've got a guide and you've got it open, you'll see they've all got dark veins, some have got colours, some have got patterns. They haven't got any of that. The body patterning here, if you look in the average guide, you'll find that you would have great difficulty identifying that dragonfly. We'll see it again later as an adult, but at the moment you would have great difficulty because you've got more or less a negative image of the dragonfly. The eyes are not coloured. Dragonfly colours are not like butterfly colours. Butterflies come out of the pupa as the full adult version. They don't have this interim tenural version. So they've got their full colours and patterns. The dragonfly doesn't have that. It develops its colour over a week or so. And then in 2 weeks' time, say when it's fully mature, it will return to the pond to mate and breed. Or it'll find a new pond away from where it was. So generally when we're looking for tenerals, adult, juveniles, things like that, we'll be finding those well away from water. The other day, I actually located a beautiful demoiselle, which we'll see in a picture, a damselfly, on top of the tree planting that we did at Newnham 2 years ago. The nearest river, it's a river-based damselfly, the nearest river to there is probably about 1.5 miles away. So that's why you find these things turning up in your gardens and all unusual places. That's the adult version of it, the emperor dragonfly, our largest flying dragonfly. You can see now he's developed more, his blue eyes become visible. These are the wing spots, the tear stigmas, wing spot. Good for identification because they're different colours, different patterns across it. Other important part on there on the wing is the cursor's gone. The point there, where you can see these coming in, these veins coming in, to join at a point and going out. This is called a node point or the node point. All dragonflies, damselflies, you can say have got these. There are a few myths we'll break in a minute, but you can say they've got them. We can see from this as a visual, if we were doing a visual of this, saw it for the first time, its eyes are touching, they're together. The wings are dissimilar. We've got a long, thin wing there. We've got a deep set wing at the back. Large, heavy body. The claspers at the back. It's pretty obvious that's a dragonfly. These are all the veins that it's puffed up. To help with that flying that we talked about, and I hope you all had a go at. This one out here, Costa, the big one, can be coloured, which helps with identification. So that one is sort of say horizontal. The next bunch in would be slightly above that. The next would be slightly lower, then above, all the way back to these very fine ones. So it formed, the wing has actually got a shape to it as well as being there. It's got an actual shape. On top of what we said before about being able to stall out wings on one side and keep wings going on the other side to move and maneuver, it can actually warp the wing membrane at the back of the wings. So that's up to our adult stage. We're going to the mating stage now. So we've moved through that adult. We're looking at the mating. We've obviously got, you should all recognise now, a damselfly on the left, a dragonfly on the right. Damselfly, wings along the length of the body, Dragonfly, wings out at 90 degrees, or that sort of area. Now this is where it gets interesting. The male locates a female, and using the claspers on the back of his, prior to him actually catching it, he transfers from this point here, which is his main genitalia, a sperm package to the accessory genitalia there below S2. So he preloads the accessory from the main genitalia. He then locates a female, and using his claspers, he locks in to the back of the female, to the back of that shield pattern on the prothorax. The shape of his claspers and the indentation patterns within the female ensure that he only mates with a female of his own type. So you can't get cross breeding between two types of damselfly and dragonfly. They don't have hybrids like you do in mammals and things like this. They won't crossbreed. They then fly in a position called tandem, where the male is flying along with the female attached to him. Then they fly along together. You'll see this on the ponds, flying together. Then the male can do nothing else. He can swing his body slightly into this position, into a downward arc, swinging the female forwards, but he can't initiate mating. It's the female that initiates mating by swinging forwards and attaching to the underside of the accessory genitalia. Similarly with dragonflies, they generally find somewhere to perch in the grass or down on the ground. The dragonfly won't mate flying. They'll fly between points, but they'll land again to mate. Mating time between these depends on the, the type of survival that each different type of dragonfly or damselfly have. There are two types really. One, to pass on your genes, you're not really bothered. You're just bothered about mating, and the female's bothered in getting as much sperm as she can. Therefore, mating in that position, they'll only mate for anything from 10 to 15 seconds to 2 or 3 minutes, because all she's doing is picking up another sperm package from a male. If there's already sperm there, it doesn't matter. The one's put on top of the other, and that's it. There's a more sophisticated method which we all think about, which is passing on our genes. So if you see the large ones, it's generally the dragonflies like this. When the female connects up with that genitalia, the shape of the rear end of her abdomen and the shape of the accessory genitalia mesh together with a series of ridges and grooves, which expels any sperm that may be present at the rear end of the female. It stops at the rear end because the eggs are actually fertilized as they pass through it, so she doesn't take it into her body. So the shape of these can take out the sperm and replace it with a new sperm. So basically simple. About the most complicated mating system I think has ever been invented, but it's been going for 250 million years. Right, now they're ready to lay eggs, we'll go on to adult egg laying. This one is an azure blue. It's again, you can recognise by now. You should be looking at this all the time. It's a damselfly. Eyes spread apart, wings down the length of the body. In both cases, very thin, slender bodies. It's difficult to say size. Size doesn't really matter because it depends on how far away you are and how you're looking at it. This is the typical position for the blue series of damselflies. There are about 6 or 7 of them, plus a few more other damselflies that mate in this position. They land on a piece of floating vegetation, leaf. In this case, it's dead weed, but it's looking at that green leaf weed underneath it. And the female stands there and uses her ovipositor, a spike at the back of her body, egg planter, to cut a slot into the vegetation and place an egg within the cells of the vegetation. Helps in two ways. If the water level drops below the point where she injected the egg, there's enough moisture within the plant to preserve the egg. So it's a safe system there. The male's still attached. He's still attached to the front at that point, behind behind that shield. And he's standing vertically, looking out for other prey. Well, not prey, sorry. He's looking out to see if anything's going to make him some prey. And if he gets a sort of thing come near him, he can drag the female out of the way. Also, if he's in this position, holding the female in that position, she's laying his eggs. Another male can't attack her, pick her up, and go through the cycle all over again. Not all damselfly. Luckily for you, I've noted this one, damselfly, eyes spread apart, wings down the length of the body. These lay on their own, the females, the blue tails. Exactly the same system. She's landing on vegetation, going under the vegetation, laying eggs with an ovipositor. That's a bit bigger. That's actually a female emperor. And she's doing the same sort of thing that the last damselfly did, lying on reed, floating. I think that's one of the lily type plants, and she's laying it into the stems of the plant, planting each egg one at a time through the ovipositor. Eyes touching, wings spread out to the side, going through it all again. Big, heavy body, big is a dragonfly. But notice here, damage to the wings. It's starting to age. This is. There are other methods of laying eggs. The eggs laid by the ovipositor are oval eggs, like little rugby balls, and planted inside the plant. There's another method, and I haven't got a photograph of it because it's extremely hard to take. The chaser, darter, and skimmers that we'll see later don't actually land. They drop the eggs into the water. They haven't got an ovipositor. That's replaced with what's called a bulbul scale, and the female flies and drops the eggs into, or dabs the water surface. So if you see one flying across, just tapping the water with her tail, she's laying clusters of eggs into the water as she goes. These eggs are hygroscopic in the way that wallpaper paste is solid until you touch it with water and it forms a gel. These eggs instantly form a gel as soon as they hit the water, and they drop down through the water and stick to the vegetation and the bottom as they go. That's a different method of laying. And then we've got the old adult. You can start to see its wings have deteriorated, its colours are changing. It's approaching the end of its life. So it's probably about 6 or 8 weeks old. The flight time of dragonflies is only within that sort of range. You can get them older, 10, 12 weeks, but generally our series are, an average would probably be about 6 weeks if it wasn't predated, if it died naturally. Right, I'll just have a drink for a second. This is where we normally have a break for coffee when we do the annual thing. Right, we've had a look at that's the life cycle, that's where they've come from and their life, that we'll see them around the ponds. The other thing that I should say about it is that unlike the ones that you've seen before. I'm last on the thing. You'd start off with butterflies, move on to bees, and then finally come through to dragonflies. Reason for that is that the butterfly is a pollinator, and everyone likes a butterfly. Bees are pollinators, and we get honey from them. So everybody likes bees. They don't like going near them because they can sting them. A lot of people are scared of dragonflies because of their size. But I've said earlier, they haven't got the strength to bite you. What looks like a sting is an ovipositor. So they cannot do us any harm at all. They're carnivores. They do not touch flowers or plants. Well, reason for that, if you think back, if you put two things together now, they come from 200 million years ago. There were no plants around 200 million years ago. There was no nectar for them to feed on. They had to be carnivores to live. So therefore, the dragonfly does absolutely nothing for us. Except they're beautiful. The colours of them are amazing, and watching them in the sunlight across a pond or a river is to me quite magical. So we'll finish our coffee break and we'll go on from this point. We're looking at where and when, basic keys, and then some physical identification.
Alan, would you like a short 5-minute break at this point, or would you like to carry on?
As long as I don't start coughing too much as we're going along. No, we'll carry on, because then it'll give us more time at the end if people want to talk, generally. Okay. First we'll look at where. Now, there are about 40, just over 40 breeding odonata within the country. People say if you want to go and look at things in nature, look at odonata, there aren't many of them. There are far more birds than there are dragonflies, far more butterflies and moths than there are dragonflies. But dragonflies are widespread throughout the country, and you can see from there across the top line, location, river, stream, acidic bog, ditch, canal and pond. All of those places you can find dragonfly, but you won't find dragonfly in all of the places. Dragonflies are specific to where they breed. Vertically down the left-hand side, we've got the sort of names of the few we're likely to see around here. I'll try to keep it to ones we tend to get in this area. So if we take the top one, for instance, the beautiful demoiselle, it's a stream expert. That's where you like to find it. It lays its eggs in fast-flowing streams. It can be found in rivers, but generally we'd say it's a stream expert. Banded demoiselle below it is the opposite way around. It's a river and it's a stream. So if you stick with those two for a minute or two, if you want to see beautiful demoiselle, if you know the National Trust property at Coton Court, as you go down the main driveway at Coton Court, you turn left over a little on back bridge into their car park. If you go and stand on that little on back bridge and look in the little fast flowing stream underneath you, you'll generally see beautiful demoiselle. If you go into the court itself and go down to the River Arrow, or in fact, if you move upstream from there, probably the best place for most people to see them, if you go to Aidan Way Walk, which is part of the trust, park in the car park, head out, and follow the path round till you come to the small bridge. It's on your left. Follow the road path round to the left till you reach the small bridge going over the Arrow there. Go onto that bridge and you'll see the banded demoiselle. We'll see these two in pictures later, but that's the type. But if you look at others, there the common orca, it's a acidic bog lover. It will come to ponds and it will go to streams, but the best chance of seeing one of those is to go to an acidic bog. When? Well, when depends on when they hatch from the water, when they're from their flight position to when they've died. So generally, if we look at the two that we just said, beautiful demoiselle, banded demoiselle, they possibly come out early May, but you generally look around the middle of May, going through to August. After that time, they won't be around. If you equate this to, say, which you know more about, if you equate this to bird watching, if I ask you in September, October to go and find a cuckoo, you'll know it's not there. It's a spring bird. So the same thing applies to these. So what we do is we put the two together and we look at it. So for May, the first half and second half of May, beautiful demoiselle, we won't find it really in a pond. I've itemised it to pond there. But the large red damselfly, we're likely to see it any time in May. It's one of the first ones out, and it's a pond, one of the pond specialists. So by linking these two together, and every good guide that you've got or that you've purchased should have this sort of thing in it. It also gives you a clue to identification. If you were to tell me you saw a beautiful demoiselle in the middle of a peat bog, I doubt whether you would do. So it would be a rogue moving through. It wouldn't be a colony animal. So jizz, now if you have a quick look at that, read that for a second or two. Right, that's Wikipedia's explanation from it for birds. Now, if I was to say to you, a bird flying in the air, what is it? It's big, it's got wings curving slightly upwards, it's got a fairly stubby tail, but it's a really big one, and it's going around in circles, going up on thermals. Nearly everybody would say buzzard. If it's got slightly shorter, bent back wings, gull-type shaped wings with a triangular tail that keeps twitching from side to side, but still flying similarly, it's a kite. If it makes a cuckoo sound and it sits in a tree, it's a cuckoo. You know, this is jizz. It's the ability we have got to recognise stuff from things we remember. Right, so if we change and replace from the above birds for odonator and we remove voice, they haven't got a lung system, they don't breathe in and out, so they can't make a noise, so they haven't got a voice, they're an insect. And also add perching to that, how they sit on reeds, how they look, how they move, that can tell us a great deal about what they are. So, as you see there, dragonfly observers have used this system since the late 18th and early 19th centuries. That's when dragonflies were first catalogued and observed and recorded. It's by using jizz they give us the basic clarification and classifications for dragonflies that we still use today. So again, if a bird person says, oh, we use jizz to identify it, this thing, we've developed it, they haven't. It's been around for a long time and used by everybody for identifying anything. Oh, excuse me. See if it comes up on this one. No, I'll go into that one. So I'll go back one. Jizz, back in the 18th, 19th centuries, when these were first recorded, generally the people who were recording them were the local clergymen. They did an awful lot of work on it. They seem to have time. And if you drive around nowadays and see how many churches, old abandoned churches there are about, there must have been hundreds of them at that time. So they had time to go out and look at stuff like this. If I was doing a survey of dragonfly or trying to find dragonfly, and I went to a local field operative standing by a pond or an edge, and I said, oh, excuse me, have you seen an emperor dragonfly? But I wouldn't say emperor dragonfly, I'd use its Latin name because I'm highly educated, that person would look at me and say, I don't know what you're talking about. But if I can say to him, have you seen a dragonfly that flies around in the air constantly? It keeps quartering the sky. It's actually hawking. Now, hawking isn't the term for using a bird of prey. There's a hawk. That comes from it. The term hawking is flying around doing this quartering of the sky, looking for something to eat or attack. If I say it's doing that, he might say, oh yeah, there's some big ones flying the other side of that hedge. That gears-wise tells me we have what we classify as hawker dragonflies present. If I say to him, have you seen one that flies low to the water surface, but certainly comes up high now and again, but it's in the vegetation at the side of the water, dashing through it, sometimes looks as if it's chasing after something. That's the chaser dragonfly. If we say, have you seen one that keeps low to the water, chasing across the bottom surface or dashing across the bottom surface, picking up insects as it goes across water, that's a skimmer dragonfly. And the last one, if it sits on a perch, and this one we mentioned earlier, as it sits on a perch, waits for something to go by, shoots out, grabs it and comes back, that's the darter. It darts out from a target and grabs it. One thing I forgot when we were talking about catching the prey, and I only just thought of it, catching prey is, as the dragonfly approaches its target victim, it brings its 6 legs underneath out, because it's had them against his body for streamlining. He'll bring them out and virtually touches the claws of his forelegs together, and then his mid legs slightly further back and his back legs further back than that, and form a basket under his body. He'll literally scoop the intended victim out of the air in a net. And then as soon as he's got it within his legs, he'll just crush it down and bring it up to his mouth. And a big target, a big fly, a big damselfly, a butterfly, a bee, they'll bite the wings off it and then carry it to somewhere where they can eat it. But going back to the gears, that gives us the 4 categories of the dragonfly, which we'll come to in a minute. So if we move again on to damselfly, that's the little drawing that I did, which we all recognise now. But now we're looking at the wing spot, the colour and the shape. Is it red? Is it brown? Is it yellow? Is it long? Is it bicoloured? So we need to look at that sort of thing for positive identification. We look at the eye colours. Are they blue? Are they red? Are they half and half? The colour of the head. Thorax. Has it got these bands down it? If it's got those bands, those stripes, is that one a solid one across here, then a thin one, then a thick one? Or is the 3 there on the side instead of 2? All these sort of things are important. The cell marking, which I said earlier, cell marking and colour of S2. You can see there S2, and it's like a little blob, funny little blob. Now, bear in mind that damselflies are about the size of an old matchstick. And that's why if you've joined the group that I take out with volunteering, we say, have you got binoculars? You need close focusing binoculars to identify these. The wing colour itself, is it transparent? Has it got markings? Has it got bands? The leg colours, are they white? As in a white-legged damselfly? Are they black? And that sort of thing. And then S8 and S9, the colour of the cells there, they're indicative of the insect. And also the abdominal colour and the length of these black stripes. They'll become more apparent when we start to see them in a minute or two. Jizz-wise, small delicate insects. They haven't got the power of the dragonfly. Even in full power, they've got nowhere near the flight capability of it. Their flight is more like a butterfly, or quite often people mistake them for daddy long legs or crane flies. They can look like that. And at rest, wings held along the body. It's going to be fun when I destroy that one. Wings held along the body. Classifications of these, we've got two classifications of damselfly in Britain that we look at, and that's the demoiselle and the damselfly. Demoiselles are slightly kept apart. The reasons why will be obvious in a minute. Right, we'll start by going into a more positive identification. And this is the beautiful demoiselle. Its Latin name, Coleoptrix. Why Coleoptrix? The first bird was Archaeopteryx. And why have I shown the demoiselle first? Well, like bird books, if you're into birding and bird books, you find the most ancient birds appear at the beginning and work outwards. The same happens in these damselflies. Obviously, this is the first of the damselfly series. You should, if we go through what we've been doing, eyes spread apart, yes, spread apart. Thorax, yeah. Wings down the length of its body, yeah. Body thin, delicate, yeah, that's thin and delicate. Pterostigma, there isn't one. So we've lost the wing spot. That puts us with this dragonfly, this damselfly, as being pre 250 million years ago, heading back to 300 million years ago. It's a direct descendant of those very, very early ones. Identification of this one, if we look at it, the wing colour, it's totally filthy. Oily blue, iridescent blue. These are beautiful. These are the river specialists. Beautiful colours. Metallic body, metallic thorax, and this dark, slightly deeper brown here. Female, slightly brownish, greeny brown, coppery coloured body, and the wings are a slight brownish, very light brownish tint. She will have, and they haven't developed, so this one isn't a full adult, but there you can see a very small mark, like a wing spot, like pterostigma. They're actually false. It does have a mark there, but it's not a true mark. This is the other one in that series that lives in England. The beautiful demoiselle is the one I said is the fast flowing river by the little bridge. This is the one you'll see all along the Arrow and the Avon. The banded demoiselle. The male's easy to tell apart, no problem whatsoever. It's still a bluish, more bluish colour than the real oily colour, but its wings are transparent or semi-transparent. For the first third, we have this blob or band across the wing where it gets its name from, and then transparent again at the back. And it looks a bit like fluttering through the breeze as it goes. Looks a bit like a First World War fighter plane with its big wing spots on it. The female, there's the white false marks on its wing. It's slightly greener than the other one. But again, in a lot of these cases, I'll be showing you the male and not the female because of certain reasons, which I'll explain. The whole thing is beautiful. These are really magnificent things to see in the light. Their method of egg laying, both of these are, they will link together in the tandem position, land on a stem, and actually walk down the stem into the water. The female will go underwater, maintaining air trapped in the legs so she can breathe while she's laying eggs. This is the large red, the first of our ones that come out that we set on a pond. This again, all of these have been spotted. But, well, this one's been spotted on the ponds within the reserves that we've got. Quite obvious. It's got red eyes and it's red. So it's a large red. It's got red down here. The female, which I haven't shown, simply for the reason there are 3 versions of it, 3 morphed versions of it. So you can get one that looks similar, but with more black in the body, more blacks. They tend to have more black up here. And then he's got a yellowy marks in here. Be very careful identifying females, because the female, the teneral juvenile, so it's juvenile, not teneral, it's slightly older, it's starting to get its colour. Juvenile male could look like a female, except the banding here will be different. It'll have more black here, the female. The blue tail, now the blue tail. Blue tail is, again, we get them, we're looking at them all the day. In this case, on this part here, this is S8, that's S9. S8 is blue, the underside of S7 and S9 are blue. So it gives us an indication there. It's got blue eyes on top there, and it's got these stripes, these patterned blue stripes and black. So that really, believe it or not, is a black, we term as a black damselfly with blue markings. And again, we'll see the reason. The female of this isn't shown because there are 5 versions of this female. So far I've recorded, I think, 2 or 3 of them on the ponds. So we keep a record of that, which we'll talk about later. Now this is a large red-eyed damselfly. We've seen that before a second ago, surely. That one looks the same at first glance, but it's got blue eye, red eyes, bright red eyes, almost like torch beams that when you see it come towards you. But if you can't see that, if you look at the top of it, it's got like a black saddle point there. There. And if we look at the bottom of it, S8, S9 and 10 now are blue. If we go back to the blue, it's different. It's hasn't got a saddle point. Now we're into the fun ones. These are blue damselflies that have black markings. Predominantly blue, and then they have black markings on top of them. This is the commonest of them all, the common blue. We pick up this, or should pick up this every survey we do. I said probably about 20 of them yesterday. Identification of this one here, we would say initially S2. If you look at that small little black blob there on top, it looks a bit like a mushroom when you look at it straight down, but the wings are in the way. So very rarely you look at it at the side and it's sort of on top like that. 8 and 9 are totally blue, a pale blue. Again, there are multiple females of this, so we haven't got them. But both of those are blue. It's like a little mushroom. This is the other one we get on the pond. It's azure. This time, if we look closely, it looks very similar there. But S2, you can see a bar going across at that point with a stripe upwards. And there's a stripe up the other side. It's like an open whiskey tumbler when you look at it. And at S8 and S9 this time, there's this black mark across here. It's not all blue. there's a black mark on it. And that black mark is like two little triangles coming together there. So if we put the two side by side, and this time I've got one that virtually looks in a similar position, there's that mushroom blob, and there's just the blue. There's that open tumbler there, and the two triangles which look like half a bow tie. So if we look at their names, I'm common because I've got a mushroom and no patterning. I'm azure, a post blue, and I've got a bow tie and a whiskey glass. So simple things like that can help you tell the difference between the two. Colour-wise, they are virtually identical. It's just the camera that gives a different colour at that point. We're going to dragonflies themselves now, the big beasts. Again, what we're looking for here are the face colour. That's that part that was sticking out in front of his eyes. Face colour, wing spots, wing colour. This will become more obvious than in the Damselfly series. Colour of his eyes, thorax stripes, patterns and colours, and then the abdomen patterns, colours all the way down here. And where possible, wing colour at base. Large, powerful insect, fast flight, appears to chase prey. I've just said that they don't chase, they intercept, but they appear to chase prey. And at rest, the wings are held at 90 degrees from the body. Right. Classification: the hawker, chaser, skimmer, and darter. Now, what we've learned so far is we can all now identify a damselfly from a dragonfly. So if we go to our great big book of whichever book we've got, whether we've got the Britain's dragonflies, European dragonflies, the National History Museum and ESC Council, is it? FSC Council spread out sheet with all the pretty pictures on. There are lots and lots of them. And I said earlier on that they're in different habitats. We won't see them all. But if we've now got this with at least 40 odd or more pictures and variations, but we can now say, well, it's a dragonfly or it's a damselfly. So we've already halved the book. We don't have to look through the book to try to find out what we're after. We only have to look through the damselflies. It's a damselfly. If it's a blue damselfly, we only have to look at the 7 blue damselflies. If we're in the Midlands here, we only look at 2 of them because only 2 of them are present. So we've already broken that book down with what we call keys to get us near the target we want. With dragonflies, we use this classification that we said earlier, the hawker, chaser, skimmer, and darter. Now, the hawker is the one that flies around looking for prey, the one that goes really fast. Now, if you're talking a fast, maximum speed, attack speed of one of these can be between 22 and 34 miles an hour, depending on which one you're talking about. But its average flying speed, its cruising speed, is around 10 miles per hour. Now, you'd equate this sort of pace that they can do to 100 times its body length per second. So if you're a fly flying along and you've got this thing coming at you, best of luck. Equivalently, if he goes into reverse, he can actually fly 3 times his body length per second backwards. So he can dodge out of the way. But we look at the hawker. They're the ones that go round up in the air, searching for food. Chasers are the ones that go as if they're physically chasing things around foliage, vegetation, by the side of the pond. Skimmers are the ones that keep close to the surface of the water, moving out backwards and forwards. And the darters are the ones that perch and dart out and grab things. So again, we go into the dragonfly section of the book. We know it's a dragonfly. Its eyes are touchy. It's big, powerful. So we go into the dragonfly side. Was it cruising around? It was. Well, we stick with the hawkers and what are called mosaics, which are the big ones. They're the ones that aren't identified in your book as chasers, skimmers, or darters. If we know it's a chaser, we go to the chaser section. There are only 2 chasers in this area. So we've limited again what we're looking for. Likewise, we only basically have 1 skimmer. So if it's a skimmer, you virtually know what it is. And darters, we have 2 or 3, quite complex to tell apart, but we know which ones to look at in the referencing code for. Right, so we'll start with one that comes out virtually the earliest in this area, and it's our largest flying insect, the emperor dragonfly. Big, very powerful. It's a hawker. It loops around over the top of the ponds. Very, very aggressive. It will chase anything that comes into its area. Be it another emperor, another orca, a chaser, it will chase it out of the area. It doesn't want it there. But when you look at it flying, it's got a very strange characteristic. Its abdomen isn't kept straight. Its abdomen is sort of hunched. It has an upward curve to it that goes back down at the base. So you can always spot these, even at a distance across a pond with your glasses. You can see that it's got this slight hunching in the body, therefore it's going to be the emperor. The brown orca. We have spotted this a couple of times around the ponds. Basically, its body's brown. It's got the 2 little blue spots on the S2, that is the abdomen. But if you notice, the wings are brown, very pale bronzy brown. It's the only dragonfly we have. Oh, excuse me. It's the only dragonfly we have whose wing is completely coloured in bronze. So that's again is an easy one to identify. Southern orcas. Now, southern orcas appear later in the season. They come in sort of towards the mid-end of summer. Quite often we see these inland. I said they don't like being around a pond when they're young. They also don't stop near the pond when they're an adult. They fly away from the pond and they feed within the forest rides. So if you're working in the forest in the evening, late summer, and you see 3 or 4, 5 dragonflies zooming around this ride with you, they're quite likely to be the southerns or the migrant dragonfly that we'll see in a minute. This is a mosaic pattern rather than a straight pattern. Very distinctive. It's got another characteristic. The female is green or green. Very similar sort of jizz that will help you out with this one. It's very inquisitive. Don't be surprised if you're standing by a pond and one of these comes right up in front of your face within 3 or 4 inches, looks at you, tries to figure out what you are and whether you're a threat, and then turns around and flies away. They will come up to look at you and will come fairly close. There's the migrant. Quite similar to the last one. It's a mosaic body, but you will now should be able to identify not what you're looking at in the field, but at least to start with, what category. Just remember what you're looking for, patterning on the body, colour of the eyes. This one's got a different eye colour, it's blue, banding around brown. They're all blue, so eyes are very important when it comes to these things. That's the common darter. We don't get a lot of them, but we see them occasionally. That's a stock photograph, not one of mine. Most of the others are all mine, that's why some of them are poor. I'm still working on them. This is a four-spotted chaser. I've shown this deliberately because it would appear to have four-tear stigma, but it hasn't. This is what's called the node point, as I mentioned earlier, between the veins. It happens to be coloured on this one. There. What's important with chasers, if you remember the last ones we looked at, were cigar shape, straight. Chasers have got a flat body across here. Most of them have got this sort of fringing colour to the edge of it. The wings will have this in the rear wing. They'll have a colour within that pattern there. If they haven't got a colour in here, they're not a chaser. So that helps you again in limiting what you're looking at. This one's four-spotted brown. The common one we see, and I've given you a female to compare against the other one. This is the broad-bodied chaser. And you'll see these on most of our ponds around where we are. The male, there are those deep-coloured patterning in his wing, very deep wing section. These are gliders, very powerful gliders as well. It's blue all the way down his body. As an adult, it's got these small fringing, yellow fringing, but they aren't very obvious when you see them, but it's got. I'm saying it's blue, adult blue, because in its immature form, it looks like a female. This blue is actually true in essence. It's a natural growth, similar to what you get on black plums, where they go purpley blue colour. That's the same, which is on that body there. It's a powder, and you can find it with it brushed off, especially if they've been mating, because the female, when she goes round, will also wrap her legs. If you saw the darter earlier, and notice she'll wrap her legs around his body and actually rub that off to some degree. The female, beautiful colours, sort of yellows down the side. This was nice light brown and dark brown inserts on the wing bases. That's the black-tailed skimmer. It's not a broad-bodied chaser. Initially, when you see these, to begin with, you can think you've got one or the other, a poor. But if you think about it, if we start to think about it, there is no marks there. None of these deep markings on the core base of the wing. There's no yellow fringing down here. Yes, he's got the blue and the black at the end. This is the one that stops on reeds like this, and then when he takes off, it will go across the water level, fairly low down after food. So if we bring the two up together there, as I said, very deep inserts, fringing down the edges. He hasn't got them. And the black is variable, and this is variable because it can be rubbed off. The final group, the darters. This is a male common darter. These are the little ones that sit on reeds and dart out and grab something, and virtually they'll come back to the same reed they started on. So if you want to try to photograph one, just sit there, find a place where they'll be, and if you haven't, stick a stick in the bank and it'll probably appear. And let them do all the work coming around. Identification of these is, it's got these yellowy, faint yellowy bars down here, and not visible on this overlay. There's a bar, there's a line there and there, like a square. These legs you can see are sort of like got yellowy in them, creamy yellow down around the edges. Nice little dragonfly. He is small. He's probably a similar size to the beautiful demoiselle. Heavier bodied, heavier built, but size-wise, he's probably not much different to a beautiful demoiselle. To confuse him, of course, we only have two darters. The rest are specialists in pink bulks, the white-faced darters, and that are specialist pig poggers. We have two locally, we have the common and we have the ruddy darter. And most people just say they've got a darter. it's that sort of difficult at times. Ruddy darter, remember I said we started way back in the bygone days naming these things and cataloguing them. We actually started before red was a colour term used for the colour we know today. If you think back in those days and you think of the village squire with his bright red nose and face because he's out all the time, he drinks too much, you'd say he had a ruddy complexion. Well, that's where the ruddy darter gets his name from, the red and ruddy. His face there at the very front is red, not yellow. And his body doesn't have those deep or those yellowy patterned markings. It's more brown, general brown all the way through. And he is what's called wasted. He goes down, he tapers to that point and then flares back out again at there. So if I put the two together, it's difficult to tell them apart, I accept that. But the other thing, the main thing is, I said he got yellowy white in his legs here, stripes. His legs are perfectly black. And that's the main recognition, quick recognition. If it's got black legs and it's a darter, it's a ruddy darter. Now I'll have to speed up a bit here, as we'll never get away. I'm going in now into what we could see in the future. We'll speed up a bit. There's when we go out on a survey, we do surveys for the group, and welcome to come along with me. We record the site location, the year, date, the start time of the survey and the finish time of the survey. That's a 20-minute survey at a pond. The average temperature, the average sunshine through that survey. So if it's sunny to start with, clouds over halfway through, it'll be 50%. Wind speed according to the Beaufort scale, wind direction, who surveyed it, because we want to know who it is, because if you come in with a suggestion, you've seen a white-faced darter, we'd want sort of to talk with you and sort of say, well, are you sure? And GPS locations and things like that are already filled in. But what the main important thing we record is the name, the number of males, number of females, were they mating, yes or no? Were they egg laying? Did we see any of them actually laying eggs on the surface? And was there any emergence, any of the exuvia located? Reason we need to know that part of it, more than these parts, is did we physically see them laying eggs on the surface of that pond? And do we know they come out of that pond? If we do, we've got a colony, so we know we've got a group there. They might only be passing through if they don't meet all that criteria. Right, observation test. You won't get long on this because we haven't got the time and you don't need it. All you need to know is dragonfly and damselfly and why. Okay, so you've all followed that. That's all the test is on that. So let's have a look. His eyes are touching? No. No. His eyes aren't touching. Cruciform position? Yes. Colour of these? There aren't any. Is a 10 or what is it? A juvenile? Yeah, it's big. Bulky body, tapering there, coming back out again. Small claspers down here. It's a dragonfly. It doesn't meet that one criteria, but it meets all the others. So the average is it's a dragonfly. It's a golden ringed dragonfly. That's the one that I said goes across South Coast and up into Scotland. Eyes touching? No, definitely not. Wings parallel to the body? Yeah, definitely. Thin body? Yes. but its colours aren't very bright, so I'm having trouble finding it. But it's a damselfly. It's actually a female common damselfly. It's bulked out here because of the ovipositor bit in here. It's not bulked up there. And these torpedo-shaped markings down the body tell me that it's a female. Eyes not touching? Yeah, that's okay. Wings parallel down the body? No, they're spread out all over the place. Long, thin body. Well, it's a damselfly because it meets that. It meets the others. It looks like a damselfly. These wings are similar in shape, so it meets that criteria. Similar shape. It's one that's on the continent is called the spread wing. Obviously, it spreads its wings. It doesn't bring them together. But in England, we call it an emerald. Slightly harder. Wings touching? No. No, eyes touching, sorry, no. Are these similar? Are they dissimilar? It's hard to say from this angle. It's got a big bulky body. And its abdomen's missing. It's actually there, bent round. But if I show you another picture of it, because you're there for a while, it's that one. See how far spread his eyes are? But it's a dragonfly. So yes, the common one is dragonfly's eyes touch, but it's not every case. This is the one case in England where they definitely don't touch. It's a common club-tailed dragonfly. That's a River 7. And you can tell from this one, I can tell it's a female, but because of the colour band. But look at the wings. So it shows that this is a towel just come out of the water. That one, well, that's our old favourite, distant cousin of the dragonflies. It's a mayfly. So there's that general knowledge, true or false. So you should be able to answer all of those now, and they're all false. Dragonflies have a nasty bite? No, they can't bite anything. Sting? No, that's the ovipositor you're looking at. Fly into your face? Well, the southern will, but he won't fly into your face. He'll come right away up to see what you are. Do they die after mating? No, the mayfly does. The dragonfly will mate during all of those 5 or 6 weeks, and then it'll eventually die, but it won't die after it's mated the first time. Dragonflies make a noise like a very angry bee. No, his wing speeds are far too slow. 30 beats a second isn't fast enough to make a noise. So the fun thing is get out there. That's actually 2 surveyors, not from here, from when I went out. No water about in that picture at all. Well, they're wearing Wellingtons. That's actually Wixel moss. That's an acidic peat bog. So they're looking for specialist peat bog things. And that should be it.
Superb. Thank you very much, Alan. That was a vast amount of information, as normal, lots to learn. I hope everyone found that useful. So we are about 8 minutes off the time I specified for this session. However, I still think it'd be really valuable if we could do any questions. So if anyone has a need to get away in a rush, you're very welcome to. We're not going to come after you for leaving now. However, if there's anybody who would like to stay for questions, I'm sure Alan would be very happy to answer those. So if you have any questions, please put them in the chat, and I believe Imogen is going to read them out for Alan.
Actually, I've got a question about mating behaviour in damselflies. So we saw lots of azure damselflies out the other day, and one was doing like the wiggly motion with its abdomen. Is that like a mating display in the males?
Were they flying or were they stationary?
They had landed and they were kind of wiggling their abdomen up and down.
Did they bend their abdomen right the way around? Were they sort of preloading the accessory genitalia?
I don't know. I think, yeah, just kind of moving it up and down.
No, but more likely not. It's a gesturing posture to other males or females present.
Yeah. Cool. There's a question from Peter, which is, how many eggs does the female lay?
It's a good question. If it's ovipositing, they're laid individually, one at a time into the stem. So that's going to take a long, long time. So probably you're talking, you know, sort of 50 or so at one time. But if they're doing these sort of just dropping, they drop in clusters. So you're far higher than that, maybe 200, 300, something like that. They're quite a lot. But we have now suddenly, I didn't mention it there, we've got a new one that I didn't jump through the bit on climate change because the temperatures are slightly rising and that we're starting to see European damselfly, dragonfly coming into England. And they may come in and breed for 1 or 2 years and then the colony will die out. That's been common for years. They're so susceptible to that sort of thing. But certainly some colonies are staying longer than they did before. And one that came over a few years ago was one of the emeralds, but it was the willow emerald. And the willow emerald actually lays its eggs, usually ovipositor, but she lays her eggs into over water branches of willow trees. She actually cuts into the bottom of the willow tree in a sliced pattern as she goes down. And they were actually detected in the Midlands last year or the year before for the first time. And things like the azure commons, things like that. If you talk about mid-France, South France, they have 2 broods a year. They wouldn't have this overwintering period of the instar. They'd sort of get one would hatch out, say in the autumn, go through the winter, emerge in the early spring, mate, and then that egg would mature again before the end of the year. So you get 2 within 1 year. That happened in France, but we're starting to see that possibly happening in England as well now.
We've got a question from Caroline, which is, with bogs drying up, is there a risk of losing some species or are there signs of migration north? Which I think you answered a little bit in your last one.
Yeah, we lost, during my lifetime, we've lost 3 species altogether. A couple of them, they're very, very specific. Although you'll see them in your books, in your referencing documents and things like this, there might only be 1 place in England where they are, or 2 places in England where they are. And if it's a bog or a fen type thing, if they drain that bog, that's the end of the species. They won't move. They're type specific, some of them, tremendously so.
Are dragonflies perceived to be a resilient species? They've been around for so long that they're less likely to go extinct with climate change?
As far as we know, yes, because if you think of it, dragonflies are throughout the whole of the world. You know, there's dragonflies everywhere. So what they'll tend to do is if we get warmer and warmer and warmer, they'll just move further away from the equator and then they'll move further back if it got colder. I mean, we're talking about through their lifetime, 250 million years. Remember, they've gone through ice ages. They've actually gone through magnetic Earth change, where the North Pole swaps with the South Pole. Which, if that happens, and it happened 42,000 years ago, for about 800 years, the North Pole moved to the South Pole and the South Pole moved to the North Pole. We had a polar change. But in that period of time, as it's changing, once it's changed, you're okay because you've got the same magnetic effect protecting the Earth. During the change, you've got more radiation from the sun because it's the polar that protects us, the polar magnetic fields that protect us from the sun's radiation to some degree. So as it's changing, it weakens, so it allows more radiation in. Well, they've been through that, you know, sort of 4 or 5 times. We wouldn't survive it, but they have. So yeah, they're very resilient.
A question from Leon: how many species of dragon and damselfly are native to the UK, and how many travel from abroad?
Well, again, it hovers around this 42 mark, breeding, but then you have got a lot coming in from abroad. Probably about another 10 or so are coming from abroad. Including from America, we get the green darners. Now the green darners, they've actually done a test on those, and Oh, let me think. I
Um,
think they did with the green darner. They did. They counted the eyes. They counted the cells in the eyes, and I think it was something like about 23,000 or something in his eye. I believe it's the equivalent of our, say, big hawk dragonfly. But as for movement, yes, the furthest flying migrating insect is a dragonfly. It's not the, if somebody says the monarch moth that goes from Canada to Florida and back again now and again, that's nothing compared to the globe skinner that can travel from continent to continent 4,500 miles. So yeah, they move around all over the place.
so you got a question from Yolanda. I was just wondering why we'd like to know which damselflies and dragonflies are where, and does it give an overall picture of habitat quality? And what's the most important reason for having lots of varied damselflies and dragonflies, other than them being cool to look at?
But that's virtually is the only reason for them. They don't do anything for us. They eat mosquitoes. So if you can train one to fly around your head when you go for a walk down the river, it might be quite nice. But habitat loss, again, yeah, they're very, very difficult in that. I mean, there was one case where the dragonfly tend to be towards the acidic side. Obviously, pig pond is acidic. So they tend to be from neutral through the acidic series. They won't go into anything else. And there was one case where a pond that was really good for dragonfly, one of the rangers working in that area found a rare or a sort of plant near the side of it that was a calcium loving plant. So he lobbed a sort of bag of quicklime into the water one day to encourage the climate for, or the ecology for this plant that he thought was rare for the whole area. Overnight, it killed every single dragonfly, and they've never come back. So yeah, you can sort of try to build an environment for dragonfly, and leaving sort of long marginal grass around the side of your ponds, like the Forest of Middle Spurnall, say, or any of the others. Don't mow grass around the edge of the ponds. If you mow it all down, the damselflies will have nowhere to go to. They migrate inwards from the pond edges into the margins for about sort of 20 or 30 meters. That's where they live, and that's really where we survey them, in the water margins.
And a question from Tasha: are white-legged damselflies in the forest? We thought we saw one the other day.
Yeah.
And another question, which I think you answered earlier: what is their role in nature?
It comes down to what is any animal's role in nature. We perceive what an animal's role is from a human point of view, from our point of view. That's why we mimic ourselves onto cats and dogs and pets. Really, animals are there because they're animals. They've evolved into that position. Well, these evolved into the position 250 million years ago. So today's environment is not where they evolved from, but they can live in our environment. So it's one of those things. They haven't got a place. They probably would have had a place as prime predator within the prehistoric times.
Great. I think that's all the questions that are in the. Yeah. I know that's it. Yeah. No more questions in the chat.
Okay. Thank you.
Superb. Well, thank you very much, everybody, for attending today. And I'm sure I say this on behalf of everyone. Thank you very much, Alan, for putting together that really useful presentation. It's really, really good. So going forward, I'd just like to raise to your attention that every week that we currently have opportunities to shadow Lucky Alan on some of our Dragonfly surveys. So if you'd like to take what you've learned today and put it into practice, there are those opportunities. My regular email is going out tonight. And of course, also, we'd love to be able to grow our scope of what dragonflies and damselflies we can survey across the forest. So if you'd be interested in supporting us with that, please do get in contact with either myself or one of the biodiversity team. But otherwise, yes, thank you very much for attending this morning. It's been a really good one, particularly good to keep out of the rain outside as well. So thank you again, Alan, and we look forward to seeing you at another training time sometime soon. So thank you very much, everybody.
Thank you.